All right, everybody, I think I'll start now. And I'm not going to go into presentation mode for the slideshow because most of the things I'm going to do, I'm going to go and show you guys examples and everything. So we're going to, and also highlight most of the words. So yeah, let's start. Okay, so hi, everyone. Thank you so much for joining and spending some time to listen into my workshop. A little bit about me. So my name is Barath, and I am a first-year mathematics student at the University of Waterloo. This is actually my first workshop, so I'm pretty excited, and hopefully you guys are too. It's a intro, more so an intro or like a glance at data analysis with Python. That's basically how this workshop is going to be. And so, yeah, let's kick start it. And for those who join later, I think they can catch up too. Okay, so let's go. Okay, so this is the workshop outline. So first, we're gonna really understand what data is, and I'm aware that most of the people that are joining are first years or people with no programming experience or maybe never worked with Python before. If you guys are one of them, don't worry. Python is a super easy language to understand, and we're gonna go into the code as well for this. But yeah. So simply, first we're going to learn what data is, and then we're going to go into more of the coding. But this part is this is the most important part of our workshop that we're going to do in the slideshows. Okay, and at the end, we're going to have a Kahoot quiz. And I made the quiz very simple and straightforward. So if you guys just listen to the workshop, I guarantee you guys winning $20, 15 or 10. So that's a really, that's a good thing to be amped up about. And yeah, so this workshop is basically in a summarized format is to learn how to work with data in Python, okay? And why, okay? So we're gonna start off by first defining what data is. So data generally, there's two types, okay? There's traditional and big data. And people put a lot of names like structured, unstructured, stored in database. You know what, we don't have to think of it like that. Simply think of it like this. Traditional data is nothing but a table. I'm sure most of you guys in high school have done plotting. So you have an X values and your Y values and you plot a graph. Similar to that. So you have X, you have Y, you have rows, you have columns. That's traditional data, okay? And then we have big data. Big data is basically anything you can think of. It's numbers, it's your credit card information, right? It could be text, string. So we generally classify big data in the 3 V's: velocity, variety, and volume. Variety is just the different formats of data. So numbers, text. Velocity is the speed of data, so how fast the data is, how fast it's being produced, and volume is just how big the data is. Okay, so that's generally what data in general is. And we're going to look at a example right now. So the biggest idea, okay, about data analysis, or as a data scientist, what you have to understand is that real world data is impure. What is impure? Impure simply means it's incomplete, inconsistent, or there's a lot of errors. Okay, that's the general idea. There's a lot of errors. And what do I mean? So let's look at a sample data set. Okay, so here is a Excel data set. Usually, this is how it works. So this is traditional data. Okay, so we have some rows. We have the rows and we have the columns, okay? So generally in a company situation, this is how it works. So as a data analyst or a data scientist, a company comes to you and says, hey, here is my data set. I have all these customers, first name, last name, gender, and they have all the information here. And they say, I want you to go through this entire data set, which if I actually scroll down for you guys, you can see it's 800 rows, which no human being is going to do it manually. And says, I want you to find me the customer base. I want you to find me the customers to target. This can be anything. This can be age, the age of the customer. It can be the area of the customer, the address, as we have over here. It can be the country in which they live in. Unfortunately, here we have only Australia, but in generally, they're, if you're looking at a more international company, they usually have different countries. And that's generally what the company says. So as a data analyst, you would say, okay, let's look at the data. Okay, so we mentioned that real world data is impure. So what do I mean? Okay, so let's look here. If we look at the first row and we look at the date of birth of this person called Chicky, this person was born in the year of 1821, But we all know that 1820, someone born in the year of 1821 is obviously not alive anymore. But it says here that in the deceased indicator, deceased is nothing but a person who is not alive anymore, in the case that somebody doesn't know. This person is, it says that this person is not deceased, but obviously this person is not alive anymore. So this is an example of incorrect data. So the inconsistency in that data, okay? If we scroll down a little bit, we can see missing values. Missing values is simply no value for that, right? Even if you go here, I actually bolded it here so we can easily find it. Generally, it's not like this. You can see this person is also not supposed to be alive, but it says this person is still alive by saying no for the deceased indicator. Okay, this is generally how the data sets are, okay, when they give it to you. So you have, as a data scientist, you have, so you see there's some missing values here, and you have this completely irrelevant column here. Like there's really nothing I can do with this. So this is all of the consideration as a data scientist, as a data analyst, that you must take care of. And nobody is going to go individually and look at all this. And that's why we use programming languages to easily go through the data. That was probably a lot of information, but let's look at it very small, in a very small graphic that I made here. So as a data analyst, as a data scientist, generally what you do is you take this data. This is more a focus towards a data scientist than an analyst because you're creating a model. But generally what people do is they take this data, they clean this data, and they work with this data, and then they put this data in a machine learning model, okay? What is a machine learning model? Simply think of it as a box, okay? This is a magic box. In this magical box, if I put some type of input, some type of data, this box tells me if that company is going to be successful in 10 years or if that company is going to be broke or what we call bankrupt in 10 years, okay? So it all depends on what we're putting into the box, into this magical box. So if I put data, so let's just take this example here. If I put this data set here, okay, into this machine learning model, this model might say, oh, the company is going to be very successful in the next 10 years. But in reality, the company might actually be doing very bad financially because the model or the data was not clean, it's not precise, it's not prepared. The outcome is completely irrelevant for the company, and it's incorrect. So the company will lose so much money from just because of this incorrect data. No matter how amazing this magical box is, if the start is bad, the whole outcome, the whole system fails. Okay, so that's a simple thing to simple thing to understand. And in terms of importance, why do we care that the data should be clean? So obviously because we don't want to get incorrect values, and so data scientists and analysts generally spend most of the time in organizing and cleaning data. Okay, this is by the way, please understand that these percentages are my own percentages, but the idea, the big concept that I want you guys to understand is that most of the time, basically all of the time, is in organizing and cleaning the data. That's the biggest part of a data scientist or a data analyst, and that's very key to understand. All right, so we talked about the whole idea of how data is impure, but how do you actually clean data? How does it actually work? So people use these two really complicated sounding names called data pre-processing and data wrangling, but generally, okay, the basic idea is that data pre-processing is just taking or gathering whatever data you want to work with, cleaning it, making sure it's perfect, and then using it for analysis. So that's the whole part of this. So it's just cleaning and preparing the data. Think of it as a diamond. Think of data as a diamond. Okay, so a diamond, when it's underground, it's very dirty. It doesn't even look shiny, right? So the whole process here is that you're taking the diamond, you're taking the data, you're cleaning it, and you're making it shiny, or in terms of or in terms of this, is correct or more accurate for a specific model or whatever. So our workshop is going to be more focused, is going to fall in this category. than data wrangling. And what is data wrangling? So data wrangling is more like the edits you do to a diamond. So let's say you get a diamond, make it shiny, right? But I want this diamond to be green. I want it to be different colors. I want it to be different shape or a different shape, stuff like that. Uh, right. So that's data wrangling, like gold, right? So I want it to be a different size of gold. That's data wrangling. The whole idea is that you take a data set and you change the shape, or you mold it, or you change it, right? So that some specific model, like a machine learning model, like we talked about, the prediction model, works better. Just basically making it work better. So you're editing the data, okay? You're editing the diamond, editing the gold. That's the idea of data wrangling. It sounds really complicated, but that's really the concept. It's not that hard to actually take it in, okay? But we're going to be focusing more on this for today's workshop. So we're going to be using something called Python. You guys probably already know we're using Python because it says it in the name, but you might not know why we're using Python, because I'm aware that some of you guys don't have any programming experiences, or maybe never used Python before or heard of it, but aren't too familiar with the term. So Python is a what we call a general purpose coding language. It's just a really cool terminology for just saying it's used for a lot of different things, okay? And it comes with all these tools. We call them packages, okay? We call them packages, and the reason for that is because they come with a bunch of methods and a lot of coding stuff. But I don't want to go into too much technicality right now. I'll go to that in a little bit. The idea is that there's a lot of tools for data analysis. It's a very quick and convenient language to use. And it's actually very easy to read, which is the main reason for why I put Python for a more introductory data analysis workshop. And generally, it takes less lines of code to do something than, let's say, Java, okay? And this is speaking from personal experience. I did an internship in web development, and let me tell you guys, it takes so much less lines of code to code in Python than it does in Java for backend. So it's generally it's a very easy to understand language. It's fast, and it's used in so many different fields like web development. Okay, let's stop talking a lot and let's go into the coding. Okay, so I'm gonna use something called Jupyter Notebook. So I'm gonna close this really quick. Okay, so I'm gonna use something called Jupyter Notebook. And Jupyter Notebook is just this very cool editor that you can use on a browser. Even you guys can do it. This is how I personally learned Python. And I encourage you guys, if you guys take a course or something, to do it on Jupyter Notebook. Okay, so generally when you're working with Python, right, before we do a lot of the important concepts, before we explain that, whenever you start a project, whenever you start doing something, you always import packages. This is what we called packages at the start in the presentation. So we import packages like this that give you certain functionality in terms of coding, okay? So for example, so we're gonna first start with loops. We're gonna start with the basic idea of loops, okay? So we're gonna look at what is called a for loop. For loop is it's a very common loop used in different languages like Java as well. And the whole idea for why we use a loop in programming in general is to do a specific task multiple times, okay? So I can manually go and print each one of these numbers, or I can simply write this code and get 0 to 9. Okay, so we're gonna break down what this means really quick. So the idea of the for loop in Python is that you give a number or you give a name for the for loop, and then you specify a specific range. Okay, so the first value that you give in a for loop is always the start value, or as we have it here, and the second value that we give is the range value. Okay, and there's also the last value, which we'll look over here. It's the step, but we'll look at it in a second. So when I run it, you can see that I get 0 to 9. Now you might ask me a question. Wait, I said the range is 10, okay? But why is it giving me 9? Isn't it supposed to give me 10? Well, let me make that really clear. In Python, we call Python zero-based, okay? Sounds really complicated, I know, but the idea is that the first part is always 0. It's never 1, okay? So if I'm gonna print 10 elements, I will get 0 to 9. I won't get 1 1 to 10, unless I specifically say I want to start from 1, and then it would start from 1 and give you 10 elements. Okay. So we'll give you start from 1 and 10, give you 10 elements. So if I say 11 in the range, then I'll get 1 to 10. Okay, so it always takes away that first element and keeps it as 0. Okay, so this is just another example of that for loop. So it just prints 0 to 4. You can see that it doesn't actually include 5. Print 0 to 4. Now you might say, wait, but you said the first element was the start number. How is it printing this? Well, when you put the number by itself without a start or a stop, it generally just takes it as range. Okay, so it's always the range, but you can specify a start or you can specify a step. You don't need it, but you do need the range. Okay, so that's what I wanted to quickly say. And here is a step. So what is a step? A step is just the difference between it. Okay, so this step, if I put 3 and I run 3, it'll be 0, 3, 6, 9. But if I put 5. So it would give me 0 and 5, and since it can't hit 10, it won't give me 10. It would just stop there. Okay, so that's the basics of it. I don't want to go too much into for loops. It's not the purpose of this workshop. We're going to go more into the concepts in a second. This is just a small example of a nested for loop, and I know it looks super complicated for people who have never programmed before. But the one thing I want to quickly mention is that Python is a very case-sensitive programming language. So let's say I have a for loop, right? Let's say I have a for loop, and let's say it does some operation. If I do a tab, okay, if I put a tab and I put another for loop, I just have, this is what we call a nested for loop, okay? So this is a for loop inside of a for loop. And similarly, I can do some random operation with that, and then I can put another for loop, and it's just a nested over nested over nested. So this is a for loop that contains in all these for loops. And I know that there was a bunch of the word for, and it's pretty confusing. But the idea is that if you tab and you go in, it becomes like a subset. Okay, think of it as a subset. So for this for is a subset of this. Okay, that's how it works in Python. So we put this in what we call a list, and we'll get to that more in a second. So we always assign some type of variable name, because I'm not going to duplicate this entire code again. I want to put everything in a small way where I can call it again. So that's why we assign, what we call is we assign a name to a specific operation, and then we just print the operation over here. So you can see it's a super long output. And I'm not going to go into the details of what this code really is. The idea is just, you have to understand, is that case sensitive. So if we use what we call the len function, which is just length, okay, it just tells you the length of how many the possible combinations here. It gives you 293. So that's just a handy thing to do. So yeah, so this is just a more of the same for loops, but in this, you could also use an operator to specify it. This is nothing but just saying 5. So that's why we have the same output here as we did over here. And this is just with steps of 25. Okay, so this is just a basic introduction to for loops. It's something you learn a lot in basically every single programming language. So it's not too much, it's not too interesting in terms of Python data analysis. We'll get to the interesting part right now. Okay, so here we have it. So here is what we call data structures. Okay, data structures. This is where we're going to go a little bit more to working with data. Okay. Okay, so what are data structures? Data structures are just easy, they're kind of like just easy ways of storing information, okay? So as we said before, we have to import all the packages that we want to work with, right? So in this case, we're not really using NumPy pandas, we don't need this. Okay, so we have to import the packages we're working with, and then we'll start with this. Okay, so first we're going to start off with what we call lists, okay? A list is what we did, we say that we put square brackets around lists, and we give them specific elements like a name or string or a number or whatever. We'll look at it more when we go through this. So when we run, so we assign this list, okay, this specific list to a to a variable, okay? And with this variable, I can call this variable again to get that specific list, okay? Generally in programming languages, this is something we do because we're not gonna write the whole list again. We wanna make it simple, and we want to be able to call it, right? And make our code simple. Okay, and we're using the same length function here, and we're getting 3. So the reason for why we're getting 3 is because we have 3 elements. Okay, that's pretty much it. Okay, so now we're going to look at something called indexing. Okay, this is a pretty important concept. If you guys are working with, you know, it's very general in terms of computer science. So indexing is the whole idea of the ability to get information from the list. Okay, so when we call 0, I get the Huey string. Now you might ask me, wait, why are we getting it when I put 0? Isn't it supposed to be 1? Well, as I said before, Python is 0 based. So the first element is actually considered 0, and then this is 1, and then this is 2. So that's why when I put 0, I got Huey. Similarly, when I put 2, normally you would say it's Dewey, but it's Louis because this is 0, 1, and this is 2, and therefore we get Louis, okay? So if I put a index, if I give it an index that's out of the range, okay, out of this range, we call it range, as we say, you can see it here, list index out of the range, it will give us an error. It will give us what we call an index error, okay? But that's not too important to understand. And we can also do indexing with a negative from the from the other way around as well. That's just something I want to show you. Okay, so now I want to tell you guys the most important part of this is that we can have any type of element in a list. Okay, so we can have a list in a list, we can have a number, and we can have a string. We can kind of mix it up. Okay, so I assign it to a variable, mix it up. I print the mix it up here, and I get it here. Okay, in other programming languages like Java, you might have to say something like system.out.println. But in Python, you don't have to say that. You don't even have to say print to print it out. You can simply just call the variable name, and it will print the output. Okay. To concatenate or append, to append a string, we simply call the append function. And so when we call back the variable, you'll have April duck in what we had before. Okay, so we're calling it on nephews. So nephews is over here. So we just added April duck here. Okay. To extend, so now to extend, we use extend is a operator if we want to use several strings. So like May duck and June duck, we use extend. Append is only for one, and extend is for any multiple of strings. Okay. And if you run it back again, you can see that we have added 2 more elements to the list. And this is another way of doing it. This is what we call concatenating a string. So nephews, as we know, is just these 3 elements, but I'm going to concatenate, and I'm going to run, nephews is this whole list, and then I'm going to concatenate, and I'm going to add these 2 strings to it and get a larger list. Okay, so this is, let me just put some nerdy term here. So this is actually what we call operation overloading. And the whole idea is that this plus addition sign is, you know how when we work with strings, it does a completely different thing. And when we work with numbers, it does a completely different thing. So the idea is that one operator is able to do 2 different methodologies, okay? Okay, so now that we have this list that we did through concatenating and extending and appending, okay, append is just adding on, extending is adding on several things, and concatenating is, again, it's just adding on more things into the list, okay? So you can also use what we call an insert, okay? And the cool thing about lists is that lists have indexes, like I talked about before. So index is nothing but saying if Scrooge McDuck is in index 0 and Huey's in index 1 and Dewey's in index 2, and then we can go in, it just goes on and on. So the idea is that if you put an index, so let's say I want 0, I want to take 0, and then I put the whatever I want to input, it inputs that in there. So instead, so we're inserting this string in the top of Huey. So therefore we have Scrooge McDuck here, so making the string even more longer. So this is 4 different ways we've checked now. Append is putting at the end 4 different ways of adding more strings. And this is only possible because it's a list. Okay, a list. This is there's so many ways of doing the same thing with the list, and that's why it's a very important and common thing we use in a lot of programming languages and concepts. Okay, so now let's say I want to delete this guy. I don't want this guy anymore. I don't want this string anymore. I can use the delete function like this and give it an index parameter 0. Okay, so this whole idea of indexing, this is the basic. I know some of the code might make you a little confused now, but the biggest idea is that with list, only with the list, you can do stuff like, with the list, sorry, not only with list, with the list, you can do stuff like indexing, okay? So you can take the index and delete 0. So 0, as we said, was the first element, right? So it would take Scrooge McDuck out, and if we print the ducks list again, we can see Scrooge McDuck is not there anymore. And we can do this by element as well. We don't need to use index. We can simply say a specific string. So I say I want to take Donald Duck out. I didn't give it a number here. You see that? We never used delete function. We're using remove. So we're not giving a number here. We're giving an element, like a actual string. And if you print it back again, Donald Duck, which was before Daisy Duck, is gone. Okay. All right, so we also have functions like sort. Sort simply just sorts it in alphabetical order. So April Duck was here, and after the sort function, we have April Duck at the start. We can also do this with reverse, doing it in the reverse direction. Okay, so having this is not too important, but it's good to know that this is possible. And so that's basically the whole idea of indexing in Python. And now we're going to look at more the slicing concepts in Python. So slicing is a really cool concept. We're still going to be using lists to demonstrate slicing. Slicing is when you're using this when we're using colons to get different data from a string, a list. So if I have 0, okay, I start from 0. As we said, what is 0? 0 is your first element here, right? And that's because Python is 0 based. So when I said 0 here, it's going to give me 1, and then 2 will give me 4. Now you might ask, wait, pause. You said Python was 0 based. So doesn't that mean 2 should be 9 and not 4? Why is it 4? Well, the reason for that is because it only works at the first for the first part of the slicing section. And this is one of the most confusing. This is one of the biggest, most confusing concepts in Python, and we'll see more of this as it comes. But the whole idea of when and where Python uses the 0-based is kind of confusing. But with more practice, the only way to do this is with more practice, you will get a better feel for it. Okay, and so if we don't specify a given, so instead of giving a number here, we just leave it like that. It will give me everything before the 4th element. So the 4th element is 1, 2, 3, 4. So this is 16. So everything before 16. Okay. Similarly, if I do it the other way, if I start from the 3rd element, okay. So the 3rd. Okay. So we're starting 3 here. So it wouldn't start at 25. It would start at 16. Okay. So putting 3 here and or putting the colon like that. So it would print everything from the 3rd element and to the right. So 16, 25, 36, 49. And if we do nothing on the left or right side and simply put a colon, it'll just print the whole element list again. Okay, so this is what we call slicing. Okay, and this is slicing by steps. You can do it by step as well. So we start at 0, so at 1, and we do it by 7 and 2. We could do it in the reverse order as well. These are not too important. It's good to know them. It's good to have a feel for them, but they're not very crucial as a beginner to start off. So you also do slicing in the negative direction as well. And yeah. Okay, so if you want to, let's say, okay, so we have this list here. So we have 1 to 49, right? But let's say I want to change 9, this digit 9. I want to put 4 in there. Okay, I want to put this string here. I want to put this, let's zoom in real quick. Okay, I want to put this string 4 in replacement of that. Can I do that? Yeah, so lists are immutable. I mean, sorry, they're mutable. Okay, so mutable is a term for a cool or fancy word of saying changeable. You can change lists, okay? So I can say, okay, I can say the second element, and as we said, it's 0 based, so it goes 0, 1, 2, so it's 9, right? So 9 will be switched for the second one, so we're giving it 4, And for the fourth element, it doesn't count from 0, so it would count 1, 2, 3, 4. So it would switch 16 with string 9. So there we go. So we have 1, 4, string, string, and then our numbers. And similarly, we can do the same thing. We can use the same delete operation that we did. Let me just you guys might have forgot. Before we did delete with indexing. Indexing is the whole idea of getting a number, right? Getting a number. So this is indexing. We can do delete operations in that way as well. And we can also do delete operations with slicing. Instead of giving an index, we can just slice. Oh, I want to delete from 4 to 6, and we'll delete those and give you a string like this. Okay, so if you also get the length of a string of an empty list, you will get 0. That goes without saying. And then yeah, that's basically it for slicing. So as you can see, it's very easy to manipulate data, that data structure list, and get different elements. This is very important when it comes to working with actual data sets. And we'll see more as we work with the packages as well. Okay, so this is really a really small introduction to tuples. Tuples, right? Okay, so a list has this, a tuple has this. Sorry, has this. That's it. That's the real big difference. But a tuple you cannot change. You cannot change any one of these elements. So you see how here we put for 2 I put 4, for 4 I put 9, and I changed the whole list here. You cannot do that for a whoa, what was that? Okay, sorry guys. You cannot do that for a tuple. Okay, it's not. You cannot change it, and it's a tuple is nothing but just these brackets. And you'll hear this term a lot in general programming. So make sure to get comfortable with it. So we assign it to a variable, and we can also slice with a tuple. It's the same concepts. You can do everything we just learned with a list. With tuples, the only thing we can't do is we can't change any one of these elements in a tuple. Okay, so that's just a general. So that was probably really confusing in terms if you were a very new, a beginner to the whole idea of programming. But these concepts are. Sorry, is someone talking? Yeah. Is somebody talking? Okay. All right. I'll just continue, and then if you guys have anything, you guys can just come on the mic, I guess. Okay. So yeah. So this is working with tuples and slicing. And so now we're going to look at dictionaries, and dictionaries are literally the same thing, in pretty much the same thing, but they're a little bit different in terms of how they are handled. So dictionaries are, like we said, lists have this, tuples have this, dictionaries have this. Okay, they have these curly braces. That's what dictionaries are usually. That's how they look, and they always have a key, and they have a value. Okay, so they're separated by the comma, by the way. So each element is a comma, because each of this is an element, and this is the key, and this is the value. And you might say, wait, what is the key and value? Well, we'll get to that in a second. So we also put the semicolon to separate the key and the value. The key is always the one on the left, and the value is always the one on the right. Okay, so we assign it to capital. So the capital of the United States is Washington, D.C., and you can see from here. Okay, so we run it, and we look at the dictionary here. Okay, so now the whole idea of key value is that if I call, let's say I want Rome to be printed. If I call Italy, right? If I call Italy, I will get Rome, because Rome is associated with Italy. So that's how it works, key and a value. So if I call it key, I get the value for that. So that's how it works, okay? So if I wanted to change, so if I wanted to say Spain, I want to put Spain equals to Madrid, and I run the capitals, I will get, you can see that I'll get a new column from what I had before. So I'm giving it a key, and I'm giving it giving it a value. So I can basically add more and more elements as I go on. That's the whole idea of a dictionary. Okay, so it's very similar to a list in terms of how it can be changed and stuff like that. So if you call a country or a key or a value that is not specified in this dictionary, it would give you something called a key error, because you can't find the key. It would say, what are you talking about? What is Germany, right? But if you associate, if you associate it with a dictionary, and then if you were to call Germany, it would work because you can find it. Also, you cannot add two dictionaries together. So capitals was this, right? That's capitals. And the more capitals is this. You cannot add dictionaries together. It will not work. It will give you an error for that, okay? Let me just run this real quick. So I'll give you a type error. It's because you cannot add two dictionaries together. Sorry, I didn't actually run the thing, so I had a wrong error message. Okay, so you can, but if you wanted to add two things, you would use what we call the update method, and it would simply just put or merge two lists, two dictionaries together. So there we go, we have two dictionaries together. Okay, so instead of adding this way with an operation, we will have to do or call another function. Okay, so the delete function also works here. So here we have the delete capitals. We're taking a specific key out. Okay, so here's the key here. I'm going to completely delete the key, but because the key and value have an association with each other, the second I take out the key, I take in the dictionary. So that's important to understand as well. And so if you print it again, we can see that United Kingdom is nowhere to be seen. Okay, and then these are pretty these concepts. So we can also have multiple elements in the dictionary similar to a list. So I can have a tuple as a key and a string. I can have, so you can put anything in a dictionary for key and value, and it would still work. It's the same thing. So I don't have to have a string here like Canada or United States. I can also have a tuple and it'll still work. And you can get a hash. This is just, so in terms of a computer, this is what it looks at, which is pretty interesting. I just want to show you guys. And yeah, so if you take the length of a empty dictionary, similar to a list, you would get 0. So the basic idea is that a dictionary, a list are very similar to each other, but a dictionary has key and values, whereas a list is just element. Okay, all right. So now we're gonna look. So now that we have a little bit of our basic understanding of in pure Python, we're gonna look at a scientific package called NumPy. So NumPy, there's a lot of, they say there's a lot of cool names for it, but generally just remember it like this. NumPy is generally used for mathematical operations. So when you're looking at very big applications, you want really fast operations. You want fast arrays. You want fast performance, right? For example, if I run a calculation, let's say I multiply 1 million by 1 million in a calculator in my machine, in my MacBook, it might take 2.5 milliseconds. But in your machine, might be Windows or might be a Mac, it would be different. So that's called performance. You don't want to drop the performance. So generally, people make the speed as fast as possible for operations because they don't want to lose. They don't want to overload too much information. So that's the more technical, nerdy way of saying it. So yeah, so generally thinking about it, NumPy is used for math. Okay, so that's the simplest way of thinking about this scientific package. So we'll look at that right now. It might get a little bit more technical here. If you guys are worried that it's a little bit over the top of your head, you guys can give me, you guys can send me a question or something, or you could watch this recording again. This whole workshop is going to be recorded, and you can follow each and every step one by one. Okay. All right. So like we said before, because we're working with NumPy, we have to import this package. None of this would work. So we call it, none of this would work without importing the package. And why? And there's a reason for why we put as NP. This is a universal standard. Okay, this is a universal standard for pandas, which we'll look at in a second. We say SPD. This is a universal standard. So, so some random data scientist, if he looks at your code and says, "Wait, what is NP? Oh, NumPy." Hey, he'll be able to understand that. So that's something. That's a small tip for you guys. If you guys are importing, you can import this as anything. You can even say like name. I guess, I don't know. You can say anything you want to say, but make sure to follow the protocols. Generally, people have best practices, and this is one of those important best practices people follow. Okay, so let's stop talking and get to this. All right, so we're going to look at what we something called array. Okay, and an array is very, as you can see, it's like super similar to a list, but it's actually pretty interesting. Okay, so with the NumPy, we simply just call the array function, and we just input a list to the array, and if we run it, we'll get the array here. And it's very similar to how the list worked when we put the length. We'll still get 3 because there's 1, 2, 3. It's very similar. And okay, so this is the important part you have to understand. So here again, I put 1 here. I'm calling 1 here, but I'm getting 2. Normally you would think it's 1, but because Python, again, I'm stressing this again because it's a very important concept. Python is 0 based. The first element is 0, and then this is 1, and this is 2. So that's why when we call 1, it's not 1, but it prints out 2. Okay, so this is a form of slicing that we just looked at, being able to get it from the index. Okay, all right. So if we look at the type, we can see it's NumPy. Okay, so the types are something we're going to be looking at a lot here. And if we look at a D type is nothing but data type. Okay, so this is integer 64, and we'll get it's hard to explain without a given example, which I'll give you guys with the pandas example, but you'll get more understanding here in a second. All right, so here, what we're gonna do, so you can change the D type and generally, okay, so here we have 64, but if I say I want to do 32, I can simply write an array, and I can give a parameter to say it has to be 32. Now again, I'll give you guys an example for why we want to do this. What is the whole importance of why we want to change a data type in a quick second. All right. Before we go further, let's go back here. We said that NumPy is used for fast arrays. Okay, so what do I mean by that? What do I mean? Why am I stressing fast here? Okay, so let's go back here and look here. Okay, by the way, this is multiplying 2 arrays with each other. So if you have 1, 2, 3, and you have 1, 2, 3, what happens is 1 times 1 gives you 1. 2 times 2 gives you 4, 3 times 3 gives you 9, and therefore you get a total array like that. Okay, so that's operation. That's basically operating with 2 arrays, and arrays are very easy to work with like this. Okay, so as we said, why am I stressing fast? With NumPy, with this scientific package, why do people prefer this? Why is this one of the most fundamental packages people use? Okay, so the idea is that like I gave you guys an example. So if I have 2 random seed numbers, these are floating points of a million. So if I multiply both of them, it takes me 6.77 milliseconds on my computer to compute this operation. But for you guys, it could be 2.65, it could be 3, it could be anything, right? So always, generally, not just for Python data analysis, or it's generally in programming, what you want to do is you want to make your operations as fast and as quick as possible. So that's why we use tools like NumPy, which give us this functionality. Okay, all right. So looking back at the array, so as we said before, we had 2 inputs for array, but you can create something called a matrix, and this is a little bit more. This is going to get a little bit more technical. So if you guys have 0 programming experience, just hang on tight, because the next one is going to be a little bit easier. Sorry for actually going a little too harsh on the content, but yeah. So this is a matrix. This is something you guys will learn as you guys go along. It's just matrix is nothing but multiple arrays. Okay, multiple arrays is called a matrix. It's a 2-dimensional array. That's what they call a matrix. And a matrix generally looks like this. So you might ask, wait, what is the significance of a matrix? Why would I want to know how to do this? In a lot of machine learning and data science calculations and models, matrix and scientific calculations, matrices come a lot. Like they're one of the biggest seen operations there, and you guys will see as we go along with the term and do a lot of these projects. Okay. So as you can see, this takes a lot of effort to write. I have to go put these brackets and everything and put all of this, right? But is there a simpler way of writing this entire code simply, like in a second, in an instant? Yeah, you can. So you can use NumPy comes with that as well. So another functionality comes with. So it comes with something called a range, and it gives you an array with 12 elements, right? And by just reshaping this data structure, okay, reshaping, these are all key terms you guys want to make sure you guys understand. We reshape a data structure to get into 4 columns, 4 rows and 3 columns. Okay, it's always rows first and it's columns second. It's always and columns second. Okay, and we can do both of these operations in a simple line like this instead of writing this entire complicated line. Okay, so just some functionality that NumPy comes with. And generally in Python, when we write a method, like for example, a range, we can call another method by putting a dot like this. Okay, so that's why we call a range here, and then we put dots and then reshape, and it reshapes that data structure into whatever we want. So in this case, 4 rows and 3 columns. Okay, and if you want to get the shape of a matrix, you just call that shape, and this is another example of just the same thing over here. Okay, so you can index again. So generally, how indexing works for a matrix is similar to how we said before. Python is 0 based, so this is not the first row. This is row 0. This is the first row. So when I call 0, I get what you call the actual first row. Okay, so it's the same thing here, and yeah, that's pretty much a overview of the scientific package for NumPy. And so I don't want to take too much time. Let's go. I want to show you guys the more interesting part. So this is the real cool part of a data analysis or data science, is the whole idea of working with data. And I'm going to do this with pandas, because pandas is one of the most used Python libraries there. If you guys are working with Python and data analysis and just working with data in general, you will see pandas literally everywhere, because it's a very versatile package. And I have a slide here real quick to show you guys. It supports all types of data. Okay, it's mixed types of data. It's very efficient with big amounts of data, and there's also more, as we looked at slicing, right? We looked at slicing with pure Python. With pandas, they make it even more simple, although it was already very simple. And there's also a lot of strong plotting elements associated to it. But we're not going to look at a lot of plotting for this workshop, but it's good to know. Okay. So Python, pandas has this very cool. Again, we imported it as PD because this is a best practice, and I'm stressing this because it's very important to put the commonality in your code so that people can understand what you're saying. All right. So yeah, so pandas comes with this very fun easy way of reading a file, and that's called the read CSV method. Okay, so this is something you will see pretty much in most real world situations. A lot of data scientists use this because it's a very easy way to read a file. So in pure structure, in a pure if we were doing this in pure Python, it would take it would take like 4 or 5 lines code, but in pandas you can do it simply in 1 line of code. And really quick, I want to just show you guys this here. So this is a CSV file, right? This is a CSV file, and in a real world situation, people, or nowadays actually, people generally data comes in both JSON formats or CSV formats. There's also other types of format like XML and blah blah blah. But the general idea is that CSV is actually what you get if you save a file in Excel. Okay, so you can try for yourselves as well. CSV is very easy to import, very easy to read, and super easy to work with. So it's one of the most common types of files you guys will see. And yeah, so this file that we're specifically working with, if I actually if I open it directly, this is actually what we're working with, is a bunch of rows. But no human being, again, is actually going to spend time manually looking at all of this. So that's why we use Python to look at it. Okay, so what we do is we call it df, and df is it's just data frame. Okay, data frame is just a table with the rows, with columns, with x and y's. Okay, so we print the data frame, and this data, as we looked at, is super long, so it doesn't actually print the whole thing. It will print the first 5 and the last 5 elements of the data frame. And you can check the length like we did in all the previous ones. It will show me 740, although it says 739. Again, I'm saying it, Python is 0 based. So that's why it's 740, because if you see here, it starts at 0. So there's 740 elements in this data frame. And then to just see the columns, we just put dot columns, and we'll get the index with all our columns here. And to just double check, we have it here: time, latitude, longitude, height, all over here. Okay, so now you can see it tells us D type. It says object, right? In pandas, object just means string. Okay, so if you every time you see object, just think of string. Okay, I don't know why they put object, but think of it as string. Okay, so I can get the info for a specific data type by just calling the info method, and see how by just some commands like this, you can get a whole bunch of information you probably can never get by going through this. So that's why we use programming languages to work with very high volume of data and stuff like that. Okay, and if you write the head, if you just put dot head, we get the first five elements. And similarly, if we write tail, we'll get the last 5 elements. Okay. Okay, so we're going to look at D types now. So I said before, we're going to look at data types. So why is data types so important? Okay, so this is why. And generally, right, when you're working with data, if you look here, you can see time is object. Object, as I said in a second ago, object is nothing but string. Okay, just think of it as string. So time is in the string format. Latitude is in the float format, and all this is correct, okay? But time, generally string is fine, but I don't want to use string here. Yes, in certain operations, in certain applications, your data type is best off with being more compatible. So for example, I need to get it to date time. I need to change object or string to date time to have for my application to work. So programming, or in this case, Python lets us do that. So what you can do is I can do data frame. I can read the data frame. This is exactly what we did here, by the way. This is exactly the same thing, but now I'm just adding this this section to it to make that a date time object. This again, you cannot do manually. So this is the power of programming. Okay, we can also get like this is slicing. We looked at slicing, right? So it was like a few minutes ago. This is slicing here. So this is a real use of slicing. Okay, so we're getting a column. We're getting a specific column. We want to look at all the values for a specific column. Okay, and again, okay. So one thing I want to make sure you guys understand is, okay, this is a best practice. Okay, I really, not just me, pretty much everybody who does this never slice like this. Never slice with a dot. You would get the same results. Okay, you're gonna get the same results, but never slice with a dot, and do it with a square bracket. And the reason for why I'm saying that is, let's say it's not lat. Okay, let's say it's called lat number. Let's say it's called this. Okay, if it's called lat number, you see how there's a space there. So if I'm gonna say df.lat number, this is incorrect. This won't work. Okay, this won't work. Similarly, if I say df lat number, this is totally fine. Okay, so that's why this step, if you call it with, if you slice it with these square brackets, it's always works. Okay, so this is a best practice when you guys are working with data frames and data. So just make sure to not necessarily, you can use dots, but you don't have, I would discourage using that, because although you get the same information. Okay, and you can also do the same thing by putting two columns. You're getting 2 columns, right? And also you could specify a column, and then you could specify an index. We looked at indexing. It's getting a specific index, so we get 35 this. So where is this value coming from? Okay, let's go back. So 0. See, 0. We're calling it from this index 0, 35015 for latitude. And for latitude, 0, 35.015. Okay. All right. So if I wanted to get all the information about a specific row, I can use something called a lock. Okay. It gives me all the information. It gives me time, gives me all the rows. It gives me the entire row, basically. Okay. So with lock, I'm able to get the entire row. So we looked at slicing as well. I'm pretty sure I showed you guys slicing. So you see how it's being used here for when we're working with pandas and in a real use case. So I can get from 2 to 7. Now this is the confusing part. Remember I told you guys slicing at the start, it always says 0 base, so it takes a 0. So it doesn't actually start from 2, right? But it's confusing because for lock, right, when you're using lock, it actually takes 2. It doesn't use 0 base. It takes 2, and then if you say 2, it will take 2. If you say 7, it will take 7. It won't do any of the weird stuff Python does normally. Okay. And similarly, you can do the same thing with, so the same thing here with 2 columns, and then slicing it from 2 to 6. So you see how here, okay, see how when we use lock and then we did it, it was perfect. But when we don't use lock, 7, it doesn't actually include 7, it just includes 6. So this is the type of confusion. It happens a lot, and it's not too hard to fix, right? It's just, you just change number, but this is something you get used to with more programming. Okay, right. Okay, so all data frames also have an index. So they give you a range index. So they give you a start, which we saw was 0, and they give you a stop, and they give you a step. So it goes by 1 each time. So 0, 1, 2, 3, 4, 5, 6. So that's your step. Okay. And you can also create your own data frame. You don't have to import one. So I've just created one from here. This is exactly what we saw in our last Jupyter notebook. See np.arrange, it gives us 10 elements. I reshape it. This is what we call a matrix, remember? Now what I'm doing is I'm putting it in a column. Okay, so this is a use case. You see, this is a use case for a matrix. I'm making a data frame. So I'm making X, Y, and I'm giving it an index A, B, C, D, E, right over here. And I just created my own personal data frame. Okay, now I call, okay, so remember before we said lock 0 and then it worked? If you guys didn't see that, I'll go back here. See, for this data frame, when I said df.lock 0, it worked. The reason it worked here, but doesn't work over here and gives us an error, it's called a type error, is because lock works with the actual label. So the label is A, right? It's not 0. Here it was 0. Remember here where we all had numeric values? So here it was 0. The label was 0. So when I called 0, it came. But here it's not 0. So it's not an index. Remember, in index we use numbers, right? For a given element we use a number. For lock, it doesn't work like that. It takes the element. So all of these small things you will learn with more programming and more practice. But yeah. So see, instead of doing 0, if I did A, which was the label I had over here, it would work. Okay, so it would give me everything in that label. So X is 0 and Y equals 1. And similarly, I can do slicing for a data frame like this, same situation. And I can also show the index here. We'll give you the data frames index, so all the time. And so this is a little bit more complicated. I don't want to get into most of the stuff, but this is all of the simple concepts in here. Okay, so if you do index, right, it just basically gives you all the index at the times, and then you can change the index to having it to it for time. So for example, yeah, so having it to time. So when you do df time here, what actually happens, it's a little complicated. Again, 0 doesn't work, and the reason for why it didn't work was because when I did that, it made the table like this. Okay, so when I did this code here, remember we had 0 before, that changed to a time value. So that's why when I did log 0, it didn't work, because it expected me to put some time value here. Okay, it expected me to put this time value here. See, if I put a time value, it gives me it. If I put a time value for a specific date, for a specific time, it gives me all that information here. So this is why slicing and all that is important to understand, and I went through all those concepts with you guys. All right, so that's pretty much it, and I know there's a lot of information. It took a long time as well. So if you guys are confused of some of these concepts and you guys want more help, you guys can always reach out to me. I'm always on the Discord chat and everything. And you guys, all of this is also recorded, so you guys can go through all of this after if you guys have time. And yeah, I can also give you guys this Jupyter notebook for you guys to follow through. Okay, so yeah, so now it's time for Kahoots. So I'll give you guys like 2-3 minutes, kind of like open Kahoot up. It's best if you guys use your own names, because there are prizes. So the first 3, so it's if you guys did not listen before, the first place gets $20, and the second is like 15, and then the third is 10. So put your real names in there so we can keep track of who won the code competition. So I have it right here. Oops. Whoops, wait one sec. Okay, so this is the Kahoot. So I just have my name here. Put your real name here and join the Kahoot so you guys can do it. It's only 8 questions and it's super straightforward. It's not hard at all. Like you don't even need any experience programming or anything to do it. So everyone should be, it should be a fair game for everybody. And I'm not putting the song. It's really annoying. So I'll just give you guys a couple of minutes to join and we'll start this.
Hey, sorry, so you said that you were in 1A math?
Yeah.
Nice. So you've been in school for like a month?
Yeah.
Is that right? Yeah.
Yeah.
How are you liking it?
It's pretty cool. I mean, I don't like online. I wanted it in person, like having to connect with people, but it's not bad. It's pretty cool and learning a lot. And this was a fun experience. This is my first workshop too. So
Yeah, you did great. I mean, it's a pretty hefty challenge trying to teach people from scratch, so did pretty solid.
thank you. All right, we'll wait for like 1 more minute for anybody who hasn't joined, and we'll start. So we'll start at 7:02, I guess.
So how'd you get into coding?
So I've been coding since like high school, but I'm more like into like data science in terms of like machine learning and stuff. And it was cool because I used to do I used to play something called FL Studio. It's like a software. It's like to make music. I'm pretty sure you guys have heard of it. So I was like pretty intrigued by like how they created the software and stuff, and that's how kind of like I got myself into like coding and everything like that. And it's actually coding is not hard at all. It looks really complicated and stuff, but it's not hard. Yeah. All right. I think we'll start now. Hopefully everybody joined. It doesn't look like everybody did though, but we'll just join. All right. So I'm starting in 3, 2, 1. All right. So it started. Oh wait, it has its own countdown. What is this? All right. I'll just stay quiet till you guys do it, I guess. Come on, guys. This is pretty easy. Like most of you guys are doing very good though. Well, okay. This one's super easy. Okay, yeah, so it's cleaning and preparing the data. I know collecting data might have seemed like the right answer, but it's the most correct here. So, oh wow, what are you guys are doing good. Okay, this is a true or false. Yes, it's so fast. Okay, I mean it's pretty easy though. Okay, I think everybody answered. I'll skip it. Yeah, okay, that's good. Good thing nobody chose true. All right. Abhinav is doing great. Ethan's doing great. All right. This one's a little bit more complicated because you guys are going crazy. Take your time. Yeah, I think one person didn't get their answer in, but yeah, it's 3. So I will, yeah, okay, let's go to the next one. It was pretty easy. Yo, anybody chose true? Okay, let's go. Oh, this is tough. Yeah, so preparation of data before analysis. This is the best answer, so you have to probably go for something more specific. But I guess it was kind of unfair. My bad. This one's easy. Come on. This is so fast. Oh, somebody picked false. All right, guys. I remember list is anything with a square bracket. Okay, a tuple is something with a round bracket, and a dictionary is the one with the curly one. So this is a list. Making sure you guys know stuff. Nah, this one's super easy. Okay, let's check. Yeah, okay, so it's a key and value. There's an association between it, but they have both a key and value. It's not a key and association, it's key and value. Okay, so I put that to throw you guys off. I think I got a few victims. All right, so I think that's pretty much it, guys. So I'll make sure I get the names here, and then I'll update you guys with the winners. And yeah, that was pretty epic. All right, so I'll keep that in track, and I will see you guys later. And thank you so much for joining the workshop and staying with me. This is my first one, so I know I have I didn't do the best in like all areas, but I'm trying to improve myself. Thanks a lot for giving me your time and being in the workshop with me. So really quick before you guys go, if you guys could give your feedback through this form, it's a bit.ly. It's pretty short to do it. You get put in a raffle to win two $10 gift cards if you complete the form, and it's not that long as well. So and you can also give me feedback and make I don't know, help us grow, I guess. So yeah, thank you guys so much for joining, and maybe you guys can take a picture of this. I think you can put this in chat if it works. Yeah, yeah. Oh, I'm so sorry, guys. I didn't even check the chat. I'm so sorry. This is okay. That's something I have to do next time. But yeah, thank you guys for joining. I think I'll put this in the chat really quick so you guys can just go for it. Yeah. So hopefully you guys have a great day. And I know some of you guys are doing your CS 135 midterm today, so good luck on that. And yeah, I'll see you guys later. Bye, everybody.